Very good morning, students. We are discussing on pavement material and its characteristics or characterization. Previously, we have seen a lot about subgrade soil, road aggregates. In particular, road aggregates, we have seen its desirable properties, its gradation, classification of road aggregates. Now, today's our topic of discussion, that is the physical property of the road aggregates. Now, first comes in mind that what are the properties we seek for the aggregates. So these are the properties, the physical properties of road aggregate, that is size, shape, surface texture, specific gravity, its bulk density, the water absorption, soundness, the aggregate crushing value, its impact value, its abrasion value, fineness modulus, and at last the flakiness and elongation index. So these all are the physical properties of a road aggregate. So let's discuss in detail of each and every properties. The first is size. Now, the size of coarse aggregate that depends on the use, so where the concrete has to be applied. For the mass concreting work, without any complication or complicated reinforcement, the larger aggregate of 80 mm, 40 mm and 20 mm size are generally used. For ordinary construction of residential or any other buildings, 20 mm size of the maximum size that we are using for the aggregate. That is for residential and the commercial kind of building construction, we are using 20 mm. Otherwise, we are using the 80 mm, 40 mm, 20 mm size. Now, if we talk about the concrete mix design that generally we are used in rigid pavement construction, so in concrete mix design, grading of aggregate is done and proportion of each size has to be determined by using the grading curves, charts, table, and there are many other methods from where you can select the proportion of that sizes. So this is all about the size. Next is shape of aggregate. How the shape of aggregate matters when you are using it for the various function of construction, various types of construction. Shape. The shape of aggregate is an important characteristics, as the shape of aggregate affects the workability of concrete. It also affects the strength of that mixture, the strength of the particular material. In a general way, the angular aggregates are preferable to the rounded and the smooth aggregates. There are few reasons for that, and those are that the angular aggregates shows better interlocking effect, which gives a superior concrete. Also, the total surface area of the rough angular aggregate is more than smooth rounded aggregate. So hence, the bond formation will be enhanced, giving the greater bond strength. So that's why the shape of aggregates affect its property. So generally we can say the angular aggregates are more preferable for the concrete work when you are using it for concrete work. Now next property is the surface texture. The surface of the aggregate may be smooth, it may be polished, or it may be rough and dull. A rough surface that provides more area for bonding with the cement paste and it gives more strength. But where workability is required, the rough textured aggregate will be less workable and more harsh. So rounded aggregates with a smooth surface will require less cement paste and hence it increases the yield. Keeping all these things in mind, we can say that overall rough textured aggregate is to be preferred more than the smooth textured aggregate, particularly for the road construction. As we are talking here for the road construction, we can say this, but according to the need, smooth textured aggregate can be used for unimportant works. So generally we can see the rough textured aggregates are more preferable in the road construction or pavement construction. The next property, that is specific gravity. The specific gravity of an aggregate is the ratio of its density to the density of the water present. So this is used for concrete mix design, that is rigid for the rigid pavement, and if not specified, if the specific gravity is not specified, we should take the specific gravity as a 2.7. The reason is that the specific gravity majorly it varies from 2.6 to 2.8. So an average value we can consider, and that's why the specific gravity, when we are taking it as a design purpose, so we take that value as a 2.7. So this was all about specific gravity. The next property of aggregate that should be understand that the bulk density. The bulk density that refers to the density of aggregate considered along with the volume of voids, or we can say the empty spaces between the particles. That empty spaces between the particles is known as a voids, and the volume of voids we are considering in the bulk density. The density of general way sand, that is a kind of aggregate, fine aggregate we can say, the density of sand falls between 17 to 25 kilonewton per meter cube. Next property, that is water absorption. Now water absorption of coarse aggregate is measured by the percentage increase in the weight of an oven with the dry sample after the immersion in water for 24 hours. This percentage is to be taken with the weight of dry, as you keep that particular aggregates into the oven, but after immersion in the water for 24 hours. But this does not give the true picture, and many times the absorption for a period that is equal to the final setting time of cement is to be measured. When you are considering the cement as a material, at that moment the aggregates should be like the water absorption of that aggregate should be decided as per this. This gives, the water absorption gives a more realistic result that will decrease the water content in concrete, and the concrete will require a higher water cement ratio. The water absorption that will depend upon the porosity of aggregate, and more water absorption will affect both the workability and the durability of concrete. We are discussing for concrete, the reason is we are also providing aggregates for the rigid pavement and flexible pavement too, as this cement and aggregate combination is important. So that's why here the workability and durability of concrete is also to be taken into the consideration. So this is all about the water absorption, how it affect and how it relate with the aggregate. The next property, that is soundness. Soundness, that is refers to the resistance offered by the aggregates to any type of volume change. We can say the volume change that may be in temperature, that may be in alternate wetting and the drying in potable water. Now potable water, like it comes from the surface, and we can say the ground sources like groundwater. Yes. Okay. So sometimes this type of water is also known as a drinking water, because that is like kind of pure water. That's why. So the volume change that may be in temperature, that may be in alternative wetting and drying in the drinking water, we can say, or maybe in alternate wetting and drying in the sea water. Okay. Now aggregate, which are very porous, are unsound, and those are more liable to attacked by chemicals. Also, these aggregates will get broken if it's subjected to alternate cold and heat. If the weathering condition is not stable, if it's cold heat, alternate weather is there at that particular atmosphere, such type of aggregates get broken. So the soundness should be so strength or so proper, so that the aggregate will not change its volume. Okay, so soundness is like that gives a resistance to any kind of volume change. So that is called the soundness property. Yes. The next, that is aggregate crushing value. Yes. The next is aggregate crushing value. The aggregate crushing value that provides a relative measure of resistance to crushing under the gradually applied crushed load. To find out the crushing value, the test sample is to be weighed and it has to be placed in the test cylinder in the different 3 layers, and each layer has to be tempered. So the specimen is subjected to a compressive load, and that compressive load of 40 tons that gradually applied at the rate of 4 tons per minute. Now then the crushed aggregates are sieved through the 2.36 mm sieve, and then after the weight of passing material that is to be considered as a weight 2, that is W2, and now the crushed value is to be expressed in the percentage of what? The ratio of weight of total sample that we have taken at initial level, that we consider as a W1, the total weight of that particular sample, and that is divided by the weight of passing material passing from 2.36 mm sieve that we have considered as a W2. So W1 upon W2, and this ratio's percentage will give the crushing value for that particular aggregate. So a value less than 10 signifies and exceptionally strong aggregates, while above 35 would normally be regarded as a weak aggregates. So this is all about the crushing value. The next is aggregate impact value. Now, impact value test is to determine the relative measures of resistance of aggregate. That resistance of aggregate to what? To the sudden shock or the sudden impact in which some aggregates differs from its resistance to a slowly applied compressive load. The property of a material to resist the impact, that property is generally known as the toughness, and that we can determine from this particular test, that is the aggregate impact value test. So due to the movement of vehicles on the road, the aggregates are subjected to impact, that resulting in their breaking down, and the aggregate should therefore have sufficient toughness that to resist their disintegration due to impact. Aggregates to be used for wearing coats, that the impact value should not exceed 30%. For the bituminous macadam, the maximum permissible value of impact, that is 35%. For waterbound macadam, the base course, the maximum permissible value, that is defined by the Indian Road Congress, that is 40%. So this is all about the aggregate impact value. The next property that has to be understood, that is the abrasion value. So next we will talk about the abrasion value. Abrasion value gives the hardness property, impact value for the toughness, abrasion value that is for the hardness. Now this value is to be determined also to decide whether the aggregates are suitable for different pavement construction works or not. Okay, so to obtain this value, to get this value, the Los Angeles abrasion test is to be performed, and that is preferred one for carrying out the hardness property, which is standardized by IS 2386. Now this Los Angeles abrasion test, if we talk about the principle of this test, that is to find the percentage of wear due to relative rubbing action between the aggregates and the steel balls used as an abrasive charge. When you perform this aggregate, at that moment you have to put some steel balls with that aggregates, and then after you have to roll the ball for few times. Okay, so that will that will exert that aggregates kind of rubbing action or wearing tearing action, and then after you will get the abrasion value. The maximum value of abrasion, that is of 40%, is allowed for waterbound macadam base course. For the bituminous concrete, the maximum value of abrasion, that is 35. So this is all about the abrasion value. Next property, that is fineness modulus. Now fineness modulus gives a rough idea of the mean size of the particles that is present in the entire body of the aggregate. Fineness modulus will measure a coarseness or the fineness. Coarseness, that means the bigger size of aggregates, and fineness means the smaller particles of aggregates. The smaller the fineness modulus value, which means the finer is the material, and if the value of fineness modulus is higher, that means the material is said to be of the coarse aggregate. That means the whole volume of aggregates is of coarse aggregate. Now, the fineness modulus can be regarded as a weighted average size of a sieve on which the material is to be retained, and the sieve being counted from the finest. The fineness modulus of fine aggregate varies between 2 to 3.5. For the coarse aggregate, that fineness modulus varies between 5.5 to 8, and for all in aggregates, that means the mixture, that value should be between 3.5 to 6.5. So next and the last physical property of aggregate, that is flakiness and elongation. The percentage by weight of aggregate whose smallest dimension or the thickness is less than 0.6 times their mean dimension, this is known as the flakiness index of aggregate. The test is not applicable to the aggregate sizes smaller than 0.3 millimeter. Such particles easily break under the load, and therefore their use in the pavement construction, that is particularly for the surface course, must be avoided. The flakiness index for the aggregate that is to be used in the road construction should be less than 15, and in no case it should exceed 25. This is for the flakiness index. If we talk about the elongation index, then we can say this term is used to indicate the percentage by weight of the particles whose greatest dimension or the length that is greater than 1 and 1.8 times of their mean dimension. The test is not applicable to the aggregate sizes smaller than the 6.3 mm, and the elongated particles are likely to break under the smaller roads. In the construction of the pavement, the aggregates having elongation index value greater than 10 to 15 are generally avoided. Students, this value you have to catch, you have to mug up, so that you can perform well in your exams, as that it will taken in maybe the MCQ type. So for this small values, these numbers are very important for you. So I hope guys you all understand thoroughly the physical property of the aggregate. Thank you for your kind attention.